I'm Anil Kumar. Welcome to my series on vectors. We are going to introduce few terms about vectors in this particular video. We'll talk about vector notation, how to represent vectors on Cartesian plane, how to find unit vector, how to add and subtract vectors, and what is linear combination of vectors. With this brief recap, you should be in a position to answer the following 4 questions. Given two vectors a and b, we need to find the magnitude of sum of a and b. Question 2 is to find a unit vector in the direction of 2i minus 5j. Question 3. The vector AB has a magnitude of 10 units and is parallel to 2i plus 3j. Find AB. And question 4 is, show that the vectors A, B, and C are coplanar. So we'll understand linear combination with the help of our question number 4. Now to begin with, vector notation, we represent vectors in many different ways. One definitely is the arrow diagram. So we could represent vector like this, correct? So from point A to B, with an arrow like this, right? So arrow pointing the direction and the length gives us the magnitude. So if this is the point A and that is point B, then we can represent this as our vector AB. Right, so that gives you the vector notation. Sometimes we also write a lowercase letter, right? So we could even write a lowercase letter. For example, we could have a vector like this, and to name the vector, we can use, let us say, u. Right. So that becomes another way to represent it. In a Cartesian plane, we may represent the vector by its coordinate points. To give you an example, let me just create a Cartesian plane here, and we will utilize that Cartesian plane to represent the vectors shown. Let us say that the coordinates of point A are, let's say, 1 and 4, and coordinates of point B are, let's say, 6 and let's say 7. Right? So that becomes the coordinates of point from A to B. Now in this case, what we could do here is that we could represent the vector as it is in the direction from A to B, right? So that is the direction for the vector, and the magnitude you can figure out from the difference of these x1 minus x2 and y2 minus y1, right? x2 minus x1, y2 minus y1 will give you the vector AB. So if I have to find the vector AB, I could do it like this. Vector AB is equal to difference in x value 6 minus 1 and difference in y value 7 minus 4. Right? So this vector is basically equal to 5, 3. Correct. So that becomes the vector AB. Now the direction of this vector can be given by the slope of this line, right, tan theta, and the magnitude can be calculated. We can write down the magnitude of the vector AB as equal to 5 square plus 3 square square root. Using Pythagorean theorem, right? So basically, what you do is actually think like this to be a right angle triangle, and that hypotenuse becomes the magnitude of the vector. x2 minus x1, y2 minus y1, square them and add them. Perfect. So that is how you could find the magnitude of a vector. Now different ways of representing vectors, we call it vector notation. So you could represent like this A to B, sometimes we put an arrow, but that is not necessary. Or we could write it lowercase letters as shown here. We could also represent them as a column, and this could also be written as ij, right? 5i plus 3j, correct? So that becomes the vector representation in Cartesian plane. I and j are the unit vectors in the direction of x and y, correct? So this is a unit vector I, and that is the unit vector j for us. You get an idea, right? Unit vectors we also represent with a cap on the top, right? So on writing, we could also write like this. So I hope that makes a good recap of what you already know. So we have seen how to represent vectors in a Cartesian plane, and now how do we find a unit vector? Now magnitude of the vector, as I said, AB is 5 square plus 3 square square root. Now this is not 1. If you calculate this, what do you get? You get 25 plus 9, which is 25 plus 9 is 34. So what you really get is square root of 34. Now if I have to write a unit vector AB, right? So here, let me just, we have very less space here. Let me use the space itself. So the unit vector AB, which I could represent like this with a cap on the top, right, should be equal to, we need to divide it by this magnitude of whatever the magnitude it has, right? So you could write this as 1 over the magnitude of the vector, right? So you can say the magnitude of vector AB will come in the denominator, right? So we'll just divide it by square root of 34, and the vector here was 5i plus 3j, right? So you could also write like this, 5 and 3. That's a short way of writing in the form of a column, correct? So the unit vector here, you could rationalize this also, but at present we'll just write it with square root 34, right? So that could be the unit vector AB, right? Now, many times I will be using not the columns, however, I may be writing this in another form, and that is using the square brackets, right? So I'll write this unit vector as 5 over square root of 34, comma, 3 over square root of 34. Right, so that becomes my unit vector AB. It doesn't make sense to you, correct? It still is parallel to the original vector. Dividing the magnitude dividing by the magnitude of the vector gives you the unit vector. I hope that makes sense. Adding and subtracting vectors, let us do these things with the help of our examples. That will be better. So let's move on to the next page and take up question number 1. Question number 1 here is, given A 3i plus j and B as 5i minus 9j, find the magnitude of A plus B. So some different ways we could do like this. We could write A plus B, we have to add these two vectors, is 3i plus j plus 5i minus 9j, correct? So you add the corresponding elements. 3 plus 5 is 8, so you get 8i, and plus j minus 9j gives you minus 8j, right? So that becomes A plus B. So these are your unit vectors, and so we get the vector AB, right? The magnitude of this vector, the sum of A and B, is equal to 8 square plus 8 square square root, which is A square coefficients squares, right? Using Pythagorean theorem, right? Does it make sense? So definitely this is equals to 8 square root 2. So that becomes the magnitude of these two vectors. Now what we skipped earlier was how to add vectors. Now with the help of these two vectors, let me also show the method of adding vectors. We'll actually represent these vectors on the coordinate plane, and then also we can add them up. So let's do both the processes together. Okay. So let us say that this is our coordinate plane. So making a rough diagram here. I plus j, it could be represented as a position vector. Now position vectors are with tail at the origin, right? So we can start with 3i plus j. So that means you go 3 units to the right and 1 unit up, right? So that is 3i plus j. So that is your vector A on a coordinate plane. Now, from here, we have to, let me just show 5i minus 9j on the same plane. So 5i minus 9j will be, this is 3, 4, and 5. And minus 9 will mean, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the vector, which will be like this, that becomes the vector B. So what we have here is, that is our vector A, this is our vector B. Is that clear to you? Right? Now, if I have to add them, I could adopt two methods to add. I could make a triangle, or we could make a parallelogram. Right. So both. So let us, if you want to make a triangle, in that case you have to move this, the other vector, tail on the head, right? So it has to be in a flow. So you begin with A, and then you can move this vector right there with the tail on the head of vector A and go for this length. So that becomes vector B. So what you realize, and what is very important for you to understand, that vectors are not fixed. You can move them from one point to the other, right? So the vector which is drawn with their tail at the origin is called the position vector. Now, the resultant, the sum of these two, can be shown by the vector which joins the tail of the first and the head of the last, right? So that becomes our sum. If I'm saying that the sum of A and B is my vector C, in that case, this is the vector C for us, right? And that is how you show it on a coordinate plane. And straight away, reading these coordinates, we'll find the vector C also. You get an idea, right? So it is 8 minus 8. Right? So that is what vector C is. So I hope the process is also clear. How do we add vectors? At present, I utilized triangle, but as you can see, we could have completed the parallelogram also. So if I would have drawn, this is not very accurate, made a parallelogram, we would have landed up with the same result. So I hope that is absolutely clear, right? So with the question number 1, we have understood how do we add vectors, right? Let's move on and take up question number 2. Question number 2. Find a unit vector in the direction of vector 12i minus 5j. So 12i minus 5j is a vector which could be kind of like this, right? Let's say this is our vector 12i plus minus 5j. Now we need to find a unit vector in this direction. Let's call this vector as our vector A, right? So we are given that the vector A is equal to 12i minus 5j, right? So this cap is for a unit vector. We are spanning along the x and y axis. Now to find the unit vector, the first step is to find the magnitude of vector A, which is written with this absolute lines, and the magnitude will be Pythagorean theorem, right? So it is 12 square plus minus 5 square root, which is square root of 144 plus 25, right? 169, which is 13. So the magnitude of vector A, as you can see, is 13. How do we get the unit vector? Clearly, the unit vector A, which I am writing with this cap, will be the vector A divided by its own magnitude. So that gives magnitude of 1. So in this case, we know 13 is the magnitude. So we'll divide by 13 the vector, which is 12i minus 5j, right? So the unit vector is 12 over 13i minus 5 over 13j. Does it make sense to you? So that is what the magnitude will now be, unit. So it's called a unit vector. So it could be represented kind of like this. Do you see that? So it really has the same direction. However, the magnitude is now just 1 since we divided the vector by its own magnitude. Right? So that is the concept of unit vector. Let's move on and take question number 3. Question number 3 is, the vector AB has a magnitude of 10 units and is parallel to 2i plus 3j. Find AB. Okay, so we are given that the magnitude of vector AB is 10 units. Now, when I say it is parallel to 2i plus 3j, that really means that gives us the direction, correct? So what we should do here is, let's find the unit vector in this direction. So first step is to find unit vector in the direction of 2i plus 3j. So first thing is to find its magnitude, right? So the magnitude of 2i plus 3j is equal to square root of 2 square plus 3 square, which is 4 plus 9 or 13 square root. Perfect. So we get the magnitude of the vector, and therefore the unit vector will be what? Will be 2 over square root of 13i plus 3 over square root of 13j. So that becomes the unit vector. Now it is a common practice to rationalize, right? So we'll normally write this as 2 square root 13 over 13, right? I plus 3 square root 13. So you need to rationalize, especially in the test, right? Right. So that becomes your unit vector. Now I think the question is simpler. We need to find the vector AB, whose magnitude is 10, and that is the direction. So clearly, the vector AB will be what? So the vector AB will be equal to 10 times this vector, right? So 10 times our vector, which is, you could also write 2 square root 13 over 13, comma, 3 square root 13 over 13. Does make sense, right? So that is another way of representing vectors in the form of a column, right? Perfect. So that is how you could write it. Now let me write in terms of I and j. So we can say that the vector AB is basically 20 square root 13 over 13i plus 30 square root 13 over 13j. Is that clear to you? So that is how you could actually write a vector in the given direction of the given magnitude. Perfect. Question number 4. Question number 4 is, show that the vector A, which is 2i plus j, B is 3i minus 2j, and C is minus 5i plus 8j are coplanar. Now, what do you understand by coplanar? So, coplanar means same plane. Means in the same plane. You get an idea, right? So the thing is that if these vectors are coplanar, then we could have a linear combination of these vectors. So that means you can get a linear combination. So linear combination means that, let us say we could have multiplied it by some constant, right? Normally we use lambda and mu, right? So we can say lambda times A plus mu times the vector B is equal to vector C. So that is the linear combination. That's what we are trying to say, right? Now the whole idea here is to find the value of these two parameters, you can say, or the constants, right? So let's figure this out. So what we have here is A is 2i plus j, right? So we can write this as lambda times 2i plus j plus mu times vector B is 3i minus 2j, right, should be equal to minus 5i plus 8j. That's what it means, right? So geometrically, if you look at it, it's kind of like this. Let's say this is vector A, right? This is vector B. So what we are trying to say here is that if I extend these somehow, if I have to get the vector C, then the vector C could be formed with these combinations, right? So we may have to multiply this with some factor, this with some other factor to get the vector C, right? So the vector C could be, if it is on the same plane, right, represented with the combination of these two. You get the idea. So if this is our vector A, that is our vector B, then this vector here is lambda A, right? And that vector here is mu B. And this is our combination which gives us the vector C if they are in the same plane. However, if C is not in the plane, you can't do this. Does make sense to you, right? So that is kind of very important to understand, right? Okay. How do we work with this? There's one equation, two unknowns. So there could be many different combination of solutions, right? So how do we figure this out? So what we do here is that we combine the like terms. So what we have here is, as far as one equation goes, we could write this as, from here, combining the I terms, right? Let's look into these terms. We get one equation. And this equation for us is 2 lambda I plus 3 mu I is equal to minus 5i. Does it make sense to you? That becomes one equation. The other one with the j's. So we get j, lambda j, and here we get minus 2 mu j is equal to 8. Does it make sense to you? So we get two equations. We need to just solve these two equations. So the equations for us is, these are I components. We can say 2 lambda plus 3 mu equals to minus 5. And here lambda minus 2 mu is 8. Now we could use elimination or substitution to find the answer. Let me multiply this by 2. So we get 2 lambda minus 4 mu equals to 16, right? So we get that equation. Now to get mu, we will take away one equation from the other, right? So we'll take up this equation from here. So we have 2 lambda minus 4 u equals to 16, right? So if I just subtract one from the other, right? So if you subtract, what do you get? Lambda cancels, right? And here we get the value, which is in this case minus 4 becomes 7 mu, right? 7 mu is equal to, and when you do this you get 21, right? This with a negative sign, correct? So from here we get the value of mu as equal to minus 21 over 7, which is minus 3. Perfect. So as you can see, we found the value of mu. And now we can find what lambda is, correct? From this equation here, we know that lambda is equal to 8 plus 2 mu. So adding, we get our answer, right? So which is equals to 8 plus 2 times minus 3. So we get lambda equals to 8 minus 2 times 3 is 6. The value is 2 for you, correct? So we have a combination. We know the value of lambda and mu, and we can write C as a combination of A and B. That means they are coplanar. Perfect. So we can now write that the vector C is basically equal to, lambda is 2, so 2 times vector A, and mu is minus 3, so minus 3 times the vector B. Perfect. Since you can write vector C is a linear combination of vectors A and B, the three vectors are coplanar. Is that clear? Now this is a very important concept. Good recap on vectors. Perfect. Have a good look at what we did. We wrote vector C as a combination of A and B, and we found those two constants which when multiplied to A and B could give a resultant as C, right? So that is how we will find or prove that the three vectors are coplanar. So I hope the concepts are absolutely clear. So with that, we come to the end of this particular video. We have actually considered what are the different ways of representing vectors. That is the vector notation. You could write it with the arrow on the top in the form of a column or in the form of a row. You can represent this on a Cartesian plane with an arrow diagram. The length is equal to magnitude, directions provided with the arrow. This is called the tail, that is the head. You could write them as capital letters starting in the end points or with a lowercase letter giving the name to the vector. Unit vector has a magnitude of 1. So you need to divide the vector by its magnitude to get the unit vector. To add and subtract vectors, we need to use a triangle or a parallelogram. And when we say linear combination, it really means that the sum of two vectors, when multiplied with constants, non-zero, right? So both should not be zero, should give us the vector C. That is what it is trying to say. I hope all this makes sense. Feel free to write your comment, share your views. I hope you find it interesting and useful. Thank you and all the best.